All right, in this video, we're going to find arc lengths or central angles, but we're specifically going to be using kind of radian measurements to do this. Excuse me. To find the arc length or a central angle, measure in radians, consider the following kind of definition here. Suppose that a central angle of theta radians intercepts an arc of length s in a circle of radius r. Then the length s of the arc is given by the following. So we have this little formula that we can use. So the arc is equal to the radius times the angle. Okay. Excuse me again. So a circle has a radius of 13 centimeters. Find the radian measure of the central angle theta that intercepts an arc of length 18 centimeters. Do not round any intermediate computations. So that means no rounding while you're in the middle of your calculations. You round at the very end to a tenth of a degree. But during your calculations, you leave all of your calculations in your calculator, the whole number. Do not do any rounding. Okay? So I have a radius of 13. I have an arc length of 18. So I have S, that's my arc length. I have my R, that's my radius. So I can actually plug these in. I have 18 equals 13 times my angle, right? My theta. I'm going to divide by 13 on both sides, and I get 1.4 equals theta. Whoop. So that's actually all we need to do on that one. We just had to apply this little formula. Okay. So for the second question they ask us, it says a circular arc has measure 5 centimeters and is intercepted by a central angle of 20 degrees. Find the radius r of the circle. Do not round any intermediate computations, and round your end answer there to the nearest tenth. So now I know my arc length, it's 5 centimeters, and I know my central angle. So now when I plug it in, I do need to do a little bit of conversion here, because now I have the 20 degrees. I'm going to need to convert this to radians really quick. So remember, to convert the degree to radians, we multiply by pi over 180. So I'm going to take 20 and I'm going to multiply that by pi over 180. I can cancel here because 20 and 180 can divide nicely into each other. So I end up with 9 on the bottom, and it's just pi over 9 because the 20 cancels itself out, right? It's 1 over 9 essentially. So now I can go through and start plugging this in because it's in radians. I want to make sure that I convert that if they give me a degree angle. And what happened with the last one with that decimal is it would have been the division part here. So we just didn't end up with the pi in our radians on the very last one. So now I have 5 equals r times pi over 9. So I'm going to multiply by the reciprocal here because that cancels the reciprocal out on this side. And I end up with 9 times 5, which is 45 over pi, which equals r. So that taken down to our decimal form because they want it to the nearest tenth. They don't want you to type it in with pi. So I'm going to go 45 divided by pi, which is 14.3 equals r. All right, so this was finding either a central angle or an arc length in radians. Hope this helped, and I will see you in the next video.